Okay. So in these questions, we were finding the equations. We could straight away get the y-intercept, and then using y equals mx plus c. Sorry, first we get the gradient, then using y equals mx plus c, we get the y-intercept, and then just write the equation. Did you get time to practice any of these?
No, not that much. Not that
Let's do
much.
one of these and then
Okay.
we move on. Look at question number 7. Variable x and y are related so that when LGY is plotted on vertical axis and x is plotted on horizontal axis. LGY and x. On the horizontal axis, the straight line graph passing through the point 6, 2 and 10, 8 is obtained. Express LGY in terms of x. So I'm just writing this for myself. X6, Y2, x 10, Y8. So express LGY in terms of x. First of all, I'm just using this to find the gradient. Y2 minus Y1 over X2 minus X1. P by 2. Now I'm writing capital Y is equals to M into capital X plus C. Like I'm not going in this detail to write LGY. Capital Y would mean that definitely it is something other than Y. So I'm selecting this point where Y is 2, gradient is 3 by 2, X is 6 and Y-intercept is 1 time 3, 2, 3
Negative
times
7.
-7. So this is Y capital is equals to mx minus 7. Now I'm replacing that Y and X. Y was LGY, X was just X and minus 7. B part says express Y in terms of X. I'm giving answer in this form. So basically we get rid of that log. Y is equals to 10 raised to the power all of this.
So wait, we get rid of the log in the log y, right? So we carry the log to the other side.
Yes.
So we log the 3 over 2x and the negative 7. Oh no, because every number by itself is log 10, has a base of log 10,
Yes.
right? So
Yes.
then that's, okay. So that's 10 to the power of all those. Okay.
Yeah. So to convert it into this form, we need to do little more working. So I can write 10 raised to the power minus 7 into 10 raised to the power 3 by 2x. And we can still deal with this number 1 over 10 raised to the power 7 into 10 raised to the power 3 by 2x. So this is done where A is 1 over 10 raised to the power 7 and B is 3 by 2. Clear? This was sufficient by removing log, but the requirement was to change into this form. Further simplification was done.
But then how? So basically the a value is 1 over 10 to the power of 7 because that's the beginning of it. But then the second one, it was just 3 over 2 because that's the
Yep.
exponent. Okay.
Okay. If you need more practice, we can choose more questions.
Sure.
You need more?
Yes.
Okay. Okay. Select. Try question number 5. First part done.
Yes, for the first part, I got y over x equals negative 2x plus 8.
Okay.
And then second part, I'm at like the first part. So negative 5 over negative 2 equals to x. So that just cancels, just 5 over 2 equals to x.
So
And then I'll
sorry.
plug it back into the equation and I'll get the y.
So x is 2.5 and y is 7.5.
Yes. So then I have to multiply the 2. Oh, okay, yeah. So yeah, just multiply 2.5 by the 3, and yes, that's 7.5.
Next concept, finding relationship from data. When experimental data is collected for two variables, it is useful if you can then establish the mathematical relationship. It is useful if you can establish a mathematical relationship connecting the two variables. If the data forms a straight line, when the graph is plotted, it is easy to establish the connection using the equation y equals mx plus c. It is more useful, however, for the data to lie on the curve and to be connected by a non-linear equation. In this section, you will learn how to apply what you have just done in previous two sections, and to find non-linear equation connecting the two variables. Worked example 4. X is given, y is given, So if I would just focus little, like x is being just doubled from 5 to 10, two times. So 2593, I'm just checking, divided by 1596. This is not reducing two times. This is reducing 1.6 times. And then from 5 to 20, x is increasing four times. But 2593 to 983, it is again 2.16 times. The relationship is slightly different. So we see what is happening. By plotting a suitable straight line, show that
So for the
x
first part, we basically just compared it. So from 5 to 10, it was a relationship of 2. And then we compared it with the 1596, right?
it
And
was
then,
supposed to be a non-linear line. I was
yep.
just checking in case if the luck works that it is linear. Like for example, if that was linear, this was doubled, this should have halved, this was four times, this should have decreased four times, would give me a straight line. But that didn't
Okay.
happen. Obviously, that is going to be a curve,
Because the x and the y need to be directly proportional, right? If
direct or
they're okay.
so
Direct or
the,
inversely?
yeah, directly would give me this line.
Inversely would be the negative. Oh no, inversely would be curved, right?
Yeah,
Okay.
just like y is directly proportional to x, straight line, and y is equals to 1 over x
Okay.
is this curve. Okay. So the table shows the experimental values of the variables x and y by plotting a suitable straight line graph. Show that x and y are related by the equation this by drawing a suitable straight line graph. So when the equation is this, I would know that y is equals to k into x raised to the power n. So basically, I'm applying log on both sides to get rid of that n, to bring that down. LGY, that is being multiplied. Whenever we multiply, we put a sign of positive sign. LGN x raised to power n. One more step. LGY is equals to LGK plus n LGX. Slight rearranging. LGY is equals to NLGX plus LGK. I can see the y-intercept, y, this is y, this is x, this is y-intercept, and this is gradient. So how would we do that? We will make two new lines to complete the table, LGY and LGX. So LGX and another line of LGY. So using calculator, I would write all these values. LG5 is 0.6989. I'll just keep them to three significant figures, maybe. Yeah, three decimal places. So this is 0.699. LG10 is 1. LG20 is 1.301, and so on. Same process with Y. So we'll get this table, LGX and LGY. Now we're plotting LGX and LGY. LGY, LGX.
So when plotting it, how do we be the most like precise? Because these are like
No,
numbers that are to the point decimals.
no issues. This would be like
3.4?
millimeter. This would be millimeter graph. So this is, this is 1, and one small box is 0.2.
Oh, okay.
So on x-axis, see that's more, those are more small values. So they're using zero point 0.5 for this, like every small box is 0.1.
Yes.
This is 0.69, 0.1, this is 1, 2, 3, 4, 5, and next would be 6, and another would be 7. So see, 0.69 is almost zero point 0.7. So we mark it close to zero point 0.7. Then this is clearly 1. The other one is 1.301. So I would just mark it 1.3 because my naked eye cannot read it till this much accuracy. That's acceptable.
Okay.
Similarly
Okay.
for y, 3.4, 3.2, 2.993 is almost 3. Third point, 1, 2, 3. See, third point is almost 3, and so on. So we just draw the graph, and for the relationship, we already knew what were our equation. LGY equals NLGX. LGY is equals to NLGX plus LGK. So we know the gradient is N. Find the gradient. Gradient is 0.7. And then
We do so
y-intercept,
by plugging in a value from the graph, right? By
yes.
plugging a value for LGY and for LGX. But then
We
LG, like how would like we would get LGK afterwards?
afterwards, there are two more things. You practically don't need to pick up any value from this line. You can also choose any two values from the table because these are the exact values which are plotted.
Okay. So can it be something like, for example, 0.699 and 3.414, they would be one coordinate, right?
Yeah, any two values. This is x1, y1. This is x2, y2.
Okay.
Any two values, you will get the gradient, which is actually the value of n.
Okay.
And then specifically don't need to calculate for LGK. You can just read it from here. That this is the y-intercept.
And that's 3.9, it says.
Yeah, because that's intersecting between the very mid of both of these. I would preferably solve rather picking that up.
So yeah, so plugging in the values to the equation and then just getting the k after, right?
Yeah.
Okay.
So now we do have both of them, and the equation was y is equals to k x raised to power n. Y is equal to k x raised to power n. Yes. So k is now just 7943 into x and power raised to power minus 0.7. So we get the nonlinear equation.
So then don't we also need a value for x?
No, these are unknowns x and y. Two variables are connected with each other through this relationship.
Oh, so we're trying to get the nonlinear value.
Yeah, the equation only. So this is the equation. Now you can actually use this equation. Now this is useful for any value of x. We just did for, we had this table for 5, 10, 20, 40, 80. Maybe I
Yes.
need a value at 65. Maybe I need a value at 105. So I'll just plug this in and have the value of y
But then okay, so the 7943 is from the LGK, so the intercept, and then negative 0.7.
is the gradient.
Oh, okay. And then why is it that put above the x?
It was given this value. It was already given that this is the relationship.
Oh, and then
We
oh
just,
yes, and then we put LG next to it. Okay.
that was substitution. We just found the values of k and n.
Okay.
Similarly, in other worked example, x and y are given. The table shows the experimental values of the variable x and y. The variables are known to be related by the equation y is equal to a plus b x over x square, where a and b are constants. Now it says that draw the graph of x square y. So according to this given information, we would rearrange our equation and already given that it is against x, y is equals to plus bx over x square. To make x square y, multiplying this on the other side, this is x square y is equals to bx plus a. So this is pretty much clear that this is y, this is the gradient, x stays x, and this is the y-intercept.
Sorry,
So,
one moment. Can I quickly grab an eraser?
sure.
Okay, I'm back.
Okay, so we were discussing the rearranging of equation. Okay, I always draw this thing. This is not required, but this makes me understand the question. So x square y against x, and whatever the line would be, I am looking at these values, and I just need x square y and y to just foresee that if it is increasing or decreasing. So we need x and x square y. X is already there. So another line for x square y. Just trying the first one. This is 2 square into 4.75 gives me 19. Then 4 square into 2.19 is giving me 35.04. These two values are enough to judge that x is also increasing, y is also increasing. That should give me a increasing line. And here the gradient is equals to b and y-intercept is equals to a. So draw the graph of this. First we make this table and then we draw the graph. Secondly, B part says use your graph to estimate the value of A and value of B. So A and B was the gradient. Now I'm not using this for any values. I'm using these exact values. So let's just try some different values. Example, this he is using 8310 and 192. Let us use second and second last. So for gradient, I'm using 4,35 and 8,67.2. y2 minus y1 over x2 minus x1. Using calculator and punching all of this. 67.2 minus 35 over 8 minus 4. I'm getting 8.05.
So in
Is
the
that
actual question, they just rounded it.
no? He's actually getting 8 while using these two values.
Oh, but when we do it, and we get something that's like 8.05, we keep at 8.05 or do we round it?
We keep it.
Okay.
Even if we round it, we would use 8.1.
Okay.
So let's just keep it and see. That's a very slight difference. Like 0.05 upon 8 is just 0.625%. So if this is the gradient, let me see. Let me see. We'll round it because A and B were constants. Uh, Table shows experimental values when related by. Let's just keep it for now. Let's see what the difference is. And then C part is no, A and B. A was y-intercept. So I'm using the same points. Y is equals to M x plus C. 35 minus 8.05 into 4. This is 2.8. And he was getting 3 because his gradient is different. So we would just write our values, whatever we've used. So x square y is equals to gradient is 8.05x plus 2.8.
Because the examiner will understand from the points that we selected.
Yeah,
Okay.
we're using what values we used. And that too, this was like I got 35.04. The examiner just wrote 35. So that is already rounded. So we would get somehow a little varied values. Okay. Practice exercise. X is given, Y is given. The table shows experimental values of variable X and Y. Copy and complete the following table. So values of X are not changing. 0.5, 1.0, 1.5, 2.0, 2.5. And now X, Y. Product of these two, 0.5 into 1 stays 0.5. This is 3. 3.67 into 1.5 is 5.505. I'm writing 5.5. 2 4 times is 8. 0.5 times 4.2 is 10.5. It says draw the graph of xy against x. We would definitely do it when like exact and neat. When we have a graph paper, this is xy and this is x. For now, I'm just looking that x is increasing and y is also increasing, and I'm just expecting this line. Maybe we would have a negative y-intercept, but for now, just a straight sketch. When we have the graph paper, we'll plot it on exact values. Now, see, it says express y in terms of x. We can do it even if we don't have that graph because we know that we will have equation in this form. This is y is equals to mx plus c. So first of all, gradient. Let me use first and last value. Y2 minus y1 over x2 minus x1. It's 10 by 2, gradient is 5. And I'm using this first value for c. xy is 0.5, x is 0.5, c. 0.5 equals 2.5 plus c is equals to minus 2. Finally, the equation looks like xy is equals to 5x minus 2. Express y in terms of x. So done. And then it says find the value of x and value y when xy is 2. When xy is 2, this is 4 by 5 equals x. And when xy is equals to 2, y is 4, x was 4 by 5. And y is 2 into 5 by 4, 2.5. So x at that time is 0.8 and y at that time is 2.5. Any confusion?
No.
Let's just check the accuracy as well. 7.7 question 1. 0.8 and 2.5. 0.8 and 2.5. Try question number 2. Are you getting it?
Yes, I drew the graph. Now I'm just finding y in terms of x. Okay. So, okay, how do I first begin by describing my graph? Because it's non-linear and it's negative. And then
Draw the graph. Let's consider that done. Express y in terms of x, the
I
equation.
said I said it was 1 over y equals negative 0.05x plus 7.5.
Okay. And express y in terms of x. C part.
Yes.
You get this?
I'm getting 1 over y equals negative 0.05x plus 7.5.
Dictate that slowly. 1 over
1 over y equals negative 0.05x plus 7.5.
that's 7.5. Okay. So why is that x? Why isn't that 1 over x? Negative 0.05x.
Yes. 1 over x?
Oh yeah, why is that not 1 over x? Because we had 1 over y against 1 over x.
Yes. So negative 0.05 1 over x, right?
Okay, I'm taking LCM quickly. This would stay x, and that is negative 0.05 plus 7.5x. And if I take a reciprocal, this is y is equals to negative 0.05 x over negative 0.05 plus 7.5x. Hmm. And what about the d part?
Okay, so then d part would be the value of x, right? I got 25.
Getting a lot of difference. Let's try. Exercise 7.7, question 2. 1 over x, 1 over y. 1 divided by 0.1, or I'll just use this table, 10, and 1 by 0.2 is 5, 1 by 0.3 is 10 by 3, which is 3.33, 1 by 0.4 is 2.5, 1 by zero point 0.5 is 2. And then 1 by 0.111 is 9.009. I'll just write 9. And 1 by 0.154, 6.49. 1 divided by 1.176, 5.68, and 1 divided by 0.189. Maybe this is the same thing. Like you would have used the exact value, and 1 divided by zero point 0.2 is 5. And while I was doing this, I could say that these were the most close values without rounding. So I'll just use these two. So draw the graph of 1 over y against 1 over x. X is decreasing, y is decreasing. So this would be the shape. And then express y in terms of x. Already know that this is 1 over y. This is 1 over x. The gradient, I'm using the first and last value. X9, Y10, X2, Y5. Y2 minus Y1 over X2 minus X1. This is minus 4 over Y2 minus Y1. This is like this, or that way around. Both are decreasing, so directly proportional. Gradient is 1 by 2. Gradient is 1 by 2. And now I can write 1 over y is gradient times x plus c. And I'm using 2 comma 5. So this is 5, 1 by 2 into 2 plus c. 5 is equals to 1 plus c. C is equals to 4. Rewriting the equation using gradient, y-intercept, and stuff. 1 over y is equals to gradient is 1 by 2. X is 1 by x plus c. Now I'm rearranging this. 1 over y is equals to 1 over 2x plus 4. Taking the LCM on right hand side is 1 plus 4 2 times is 8x y is equals to 2x over 1 plus 8x. Is your process same?
My process is the same, but the
Well, you stick
values
to it.
inside the table is different.
Oh, and where is like the greater difference? Where does it come? 10 by 9, 10 9. Is that same?
Yeah, that was the same one, but afterwards it wasn't 5 9. I was going by different values, but then it was just one
Values of
over x anyways. Sorry.
just dictate. Is this 10, then 5, then 3.33?
Okay, I have yeah. Let me see. 10, then 20, then 30, then 40, then 50.
Okay, okay, okay. See, this is 1 over 0.2.
Yes.
So you must have punched in 0.05 to get 20. Just try that quickly. 1 over point 0.2. This gives you 5, not 20.
Yes. 5. So then just like the values for the x component. But then the y component are correct. Like they're the same ones.
So the problem lies here.
Yes.
So
But
once
then
we do,
my method is also the same as well. Like
yeah,
I've first tried getting the gradient like you did, but my gradient was like different. But then I tried like putting it into the equation and then getting the y-intercept, but just the x values.
yeah. So once we have them in order, we do get that equation. And finally, find the value of x when y is equals to 0.16. So y is already subject of the formula. So 2x over 1 plus 8x. Cross multiply is 0.16. 0.16 times 8 is 1.28 is equal to 2x. 0.16 on the other side, 2 minus 1.28 is 0.72. X is 0.16 over 0.72. And I get 2 by 9. X is equals to 2 by 9, which is approximately equal to 0.22 and 0.22 B part. And this whole exercise lies on the same structure.
And that's the end.
That's the end. Next would be circular measures. Let's try one more question. Hmm. See, the next questions are not giving you the table, the empty table. We
But
want,
they're still giving you the sentence, which then tells
yeah,
you
yeah,
to turn it.
yeah, yeah, yeah. We just have to try it ourselves. Let's do this third question to have space here. This time, try the question and I'll silently just do it with you.
Okay. Okay, I finished my table of values. So, like at the top of my table, I have XY, and I have 12.8, 15.2, 19.2, 24.8, and 32.
Okay.
And bottom, which is x squared, I have 1, 4, 9, 16, 25.
Okay. Values are correct. Just switch them. This is x-axis and this is y-axis.
Okay, because it
Yeah.
has y in it.
Yeah. This is the wording. Whenever you say draw A against B, so B is on x-axis.
Oh, okay.
See, question 1. It says draw xy against x. So xy was on y. Against x, this is x-axis. Number 2, draw graph of 1 over y against 1 over x. This is x-axis. The second one.
Yes.
Against x square, that is on x-axis. Values are correct. Just switch them.
Okay.
No need to rewrite. For second part, just keep that in mind.
I just labeled beside each one of them which one was which. I just put y-axis for xy and x-axis for x2.
Okay.
Okay, so then B part is y equals 0.8 x squared plus 12.8 over x.
0.8 x square plus
12.8 over x.
12.8 over x. Correct.
And C part is just plugging in 12.288 in front of it, right?
Right.
So then C part would be 39.054.
39.0545. Yes. See, this was question 3. Okay. 0.8x plus 12 over x. 0.8x plus 12 over x. That
So
is
the
12.
X cancel.
No, no, he's just splitted it. No issues. Like there's a cohesion. He just wrote it like this: x square over x plus
Also, then
12.
the X was canceled with each other. Okay.
And my bad. This was really 12.8 minus zero point 0.8. It should be 12. I wrote 12.8. I think both of us wrote 12.8. That's 12. Quickly
So
changing
that
this.
makes the whole thing wrong, right?
Yeah, all the parts after that. We might get error carried forward, but for now, let's just correct it. So 12.888 minus 12 divided by zero point 0.8 is 1.11. X square is equals to 1.11 and x is equals to square root 1.11 is 1.05. So last part is y is equals to 0 0.8, x square was just 1.11 plus 12 over x is 1.05.
But isn't it still 12.8 because that's the value for XY, right?
No, no, that was value for y-intercept.
Yes.
I wrote y-intercept as 12.8.
Oh, so then it would just be a 0.8 and then subtract that by that. Okay.
0.8 goes on other side and gets subtracted. So zero point 0.8 into 1.11 plus 12 over 1.05 would give 12.27. And this is still 0.6. Where is the mistake? XY was 12.2. Oh my god, another blunder. This was 12.288. I wrote 12.888. That was 2. Did you write 12.288 or 888?
12 point. I think I wrote 288.
Yeah, you
But
wrote
I
it.
think I erased it, but okay.
Minus 12 is 0.288 divided by zero point 0.8 is 9 by 25. X square is equals to 9 by 25. So x is equals to square root of answer is exact 0.6.
So 3 over 5, 0.6. Okay.
Y is equals to 0.8 into x square, 0.6 square plus 12 over 0.6. And I'm getting 20.48. Now it's correct.
Or 0.6. So
Yeah.
that's, yeah, 20.48.
Apart from the process, need to copy the question carefully as well. Okay. So do practice. Our next topic would be circular measures. This is mensuration, area and perimeter, which would involve trigonometry as well, basic
Okay.
trigonometry. Do practice few questions. See you in next class.
Thank you.